Now we are going to discuss the problems on torsion of shafts. First problem, calculate the torque in a solid circular shaft. Calculate the torque in a solid circular shaft of 120 mm dia if the shear stress is not to exceed 80 Newton per mm square. So shear stress limit is 80 Newton per mm square. So first of all, you write down the given data first. Dia of the shaft equal to 1 D equal to 120 mm. Maximum shear stress Fs 80 Newton per mm square. Now we want to find the torque T in Newton mm. We want to find the torque T equal to Newton in mm. The solution is torque in a solid circular shaft. Torque in a solid circular shaft, we have the formula. As we have formula torque equal to pi by 16 into Fs into d cubed. Fs equal to stress and d is the diameter of the shaft. So pi by 16 Fs equal to 18, d cubed is 120 cubed. So we got the answer of 27.143 into 10 power 6 Newton mm. Finally write down the result. Torque in shaft T equal to 27.143 into 10 power 6 Newton per Newton mm. Next problem. A solid circular shaft has to transmit a power of 40 kilowatt at 120 rpm. Circular shaft transmit 40 kilowatt power at 120 rpm. The permissible shear stress is 100 Newton per mm square. Shear stress permissible limit is 100 Newton per mm square. Determine the dia of the shaft if the maximum torque exceeds the mean torque by 25%. So consider the maximum torque exceeds the mean torque by 25%. First of all, you write down the given data. Power transmitted P equal to 40 kilowatt and shear stress Fs equal to 100 Newton per mm square. Then maximum torque T max equal to 125 into mean torque as they are given. The maximum torque exceeds the mean torque by 25%. So 1.25 into T mean average torque. Here to find number 1 diameter of the shaft D in mm. So dia of the shaft in mm. So solution is power transmitted by the shaft P equal to 2 pi nt per 60. Consider the average torque T mean. So T mean, from this we got T mean equal to P into 60 divided by 2 pi n. Put all the values corresponding P equal to 40 kilowatt and 60 2 pi n equal to 120 rpm. So finally we got 3.183 kilonewton meter. Just we got the unit in Newton on 3.183 into 10 power 6 Newton per mm. So T max, they given the T max equal to maximum torque exceeds the mean torque by 25%. So T max equal to 1.25 into T mean. We got 1.25 into 3.183. We got 3.979 into 10 power 6 Newton per mm. Here is the case maximum torque. So torque transmitted by the shaft T max equal to pi by 16. We have the formula for torque equal to pi by 16 into Fs into d cubed. From this we got d cubed equal to 60 into d divided by pi into Fs. So just we work out, the answer is 2022648.806. So we got answer in terms of cube root of diameter. So finally we take the cube root of this answer. We got d equal to 58.737 mm. The result is the diameter of the shaft D equal to 58.73 mm.